All right, AP loves to ask what I call graph of the derivative questions. This is a 2018 question. And again, this is the graph of G, but G is defined as the derivative of F. So it's really looking at the graph of the derivative. And we answer questions, about function values, derivatives, second derivatives, points of inflections. We, evaluate integrals. We decide when it's increasing or decreasing. We find maxes and mins, all sorts of stuff like that. And we just have to kind of be careful. Okay, so this is some crazy piecewise function. So it's a constant, it's a line, it's a constant, it's a line, it's a constant. It's some parabola right here, then from 3 to 6. Okay, so again, we're looking at the graph of the derivative. Okay, if f of 1 equals 3, what is the value of f of negative 5? Okay, so this is how I suggest doing it. F of negative 5 equals f of 1 minus what you did. And again, if you integrate g, right, you integrate the derivative, you're getting the accumulation. Since we want to go backwards in time, f of 1 minus what you did from from negative 5 to 1, that will actually take you back to where you were at negative 5. If you want to think about it in the reverse, if you added this to the other side of the equation, it would say that what you did from negative 5 to 1 plus where you started equals where you ended up, this being the future value. But if you have the future value, you can just subtract what you did. Or, of course, you can add and switch the limits. I would rather keep the limits the same and just subtract and then go backwards in time. So if you do that, you end up having to subtract this stuff. And again, the integral from negative 5 to 1 is this rectangle and then this triangle and then this triangle up there. So it's the triangle, a triangle, and a rectangle. These are negative because they're below the x-axis. That's positive up here because it's above the x-axis. And I'm going to 3, and I'm going to subtract that accumulation to get actually where I was at f of 5, or f of negative 5. All right, B says just go ahead and evaluate this integral, right? So we're accumulating the graph of derivative from 1 to 6. Okay, that's up here. So if I want to integrate from 1 to 6, I got to integrate from 1 to 3 and then from 3 to 6 because the function changes. The integral from 1 to 3, well, that's just that square, which is just a 2 by 2 square, so that's area is 4. And then I got to integrate this function from 3 to 6, and the work is all up there. Again, that's analytically, I'm sure this is a no calculator question, so I got to do this integral by hand, evaluate from 3 to 6, plug in, and I end up getting 6. And so then 4 plus 6 is just 10. So the answer there is 10. The integral from 1 to 6 of g of x is 10. All right, C. On that open interval, where is f both increasing and concave up? Okay, f. If f is increasing, that means g is greater than 0, g being the derivative of f, right? So I'm looking for when this is above the x-axis, so I'm looking up here, and I want f to be concave up, which means I want g prime to be greater than 0, because g prime is f double prime, right? And so I want the slope of this to be positive. So I want it to be above the x-axis, and I want it to be sloping up. And so we have two separate intervals, right? From 0 to 1 and from 4 to 6. It's above the x-axis, and it's going up on that region. All right, D, find the x-coordinate of each point of inflection. Ooh, okay. So of f, of course. So I want to know where f double prime changes signs, which means I want to know when g prime changes sign. And that's the graph of this derivative. So I want to know when this goes from increasing to decreasing. And that's really only at x equals 4, okay? It's kind of, this whole thing is kind of going up. There's second derivatives not actually existing there, but x equals to 4 is a point of inflection because f double prime goes from positive to negative, which is the same thing as saying f prime goes from decreasing to increasing. Of course, that's the same thing as saying g goes from, in this case, decreasing to increasing, right? A max or a min of the second derivative will lead, or of the first derivative leads to a 0 of the second derivative. So just kind of be careful on those things. Make sure you understand how all those are connected. All right, let's do another one. 2017, again, this is the graph of f prime, and we want to find the values of f of -6 and f of 5. Okay, kind of the same thing, but in this case, we know the starting value of at -2. So here, I want -6, and I have -2, so I have to subtract what I did from -6 to 2. And if I want 5, I start at -2, and I got to add what I did from -2 to 5, right? This is me adding the accumulation to where I was at -2 to figure out where I am at 5. And this is me knowing I'm at -2, and I want to know where I was at -6. I had to subtract what I did from -6 to 2 to get those accumulations. And this is just, triangles, a semicircle, and a triangle. So this is, in this case, 7 minus 4, and this one is, 10 minus 2 pi. All right. On which intervals is f increasing? F is increasing when f prime is positive. So we're looking when this is positive. So I'm looking at those two regions, -6 to 2 and 2 to 5. Okay. Find the absolute minimum value. Okay, go back to the flow rate ones. What do we do when we find maxes and mins? We do a chart. Do a chart, do a chart, do a chart. Now, when can maxes and mins occur? Well, they can occur when the derivative doesn't exist, the derivative equaling to 0, or at endpoints. So that's what I decided to do. I looked at -6 and 5 because those are endpoints, and then I looked at -2 and 2 because at -2 and 2, that's where the derivative is equaling to 0. I found the accumulation of those things, and again, I already knew that one, and I already knew that one. And I showed, oh, look at that. There's the absolute min. The absolute min occurs at an x value of 2, but the actual find the absolute min, that's this value. That's 7 minus 2y, right? The actual min value is the y value. Okay, and then part D is kind of up here. Part D says, all right, find f double prime of -5. F double prime of -5 is the slope of f prime at 5. And so we're looking at the slope over here, and the slope over here is just -1/2. And then we want the slope at 3. Well, we know the slope of 3 does not exist, right? It's a corner, or you could say that the limit of this and the limit of that do not agree, right? It goes from a positive slope to a negative slope instantly. So the derivative of f prime doesn't exist, which is f double prime. Okay? So those are the graph of the derivative questions. Very similar to flow rate, just with no story, right? You're going to accumulate things with integrals. You're going to take derivatives. You're going to look for points of inflection. You're going to look for maxes and mins, increasing and decreasing interval type stuff. And again, you're going to do a whole bunch of these as a free response.